Movement curve for a two-stroke engine is represented by the equation T is equal 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta Newton meter, where theta is angle turned by the crank from the inner dead center. Here it is a linked answer question. It consists two questions in such a way that the second question answer depends on the first question. Here the first question is the work done per revolution is, and here the second question is if speed of the engine is 180 rpm, power developed by the engine is. So coming to the solution, here the turning moment curve for the engine is represented by an equation that is T is equal to 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta. So here the turning moment curve is a function of 2 theta. So but for a two-stroke engine, work done for every revolution of for every angle movement by the crank from inner dead center to outer dead center, that is 0 to 2 pi. So but it is a function of 2 theta, so that's why so work done per revolution is given by it is 0 to pi t d theta. So here from this equation 0 to pi it is 20,000 plus 9,500 sin 2 theta minus 5,700 cos 2 theta. So from this integration we can get here it is equal to 20,000 pi joules. So that in the option the right option is A. A is the right answer for the first question. And here coming to the second question, if the speed of the engine is 180 rpm, power developed by the engine is equal to 2 mean torque into 2 pi n by 60, that is where n is the 180 rpm. So here T mean torque is equal to 1 by pi into work done, so which is equal to 20,000 joules. So from this equation it is 20,000 into 2 pi into 180 by 60, which gives a value of 377 kilowatts nearly. So in the options the right option is D. D is the right answer for the second question. In a gas turbine power plant working on Brayton cycle with regenerate of 75% effectiveness, the air at the inlet to the compressor is at 0.1 megapascal and 30 degrees centigrade. The pressure ratio is 6 and maximum cycle temperature is 900 degrees centigrade. The turbine and compressor have each an efficiency of 80%. Here it is a linked answer question. It consists two questions such a way that the second question answer depends on the first question answer. Here the first question is the cycle efficiency without regenerator will be, and coming to the second question, the percentage increase in the cycle efficiency due to the regeneration is. So here first we will have to draw the Brayton cycle. So draw Brayton cycle on TS coordinates. So the ideal Brayton cycle is like this. So let us say this is the point 1 and here it is 2, 3 and 4. Here 1 to 2 is compression process and 2 to 3 is heat addition and 3 to 4 is expansion in the turbine and 4 to 1 is heat rejection. So this is the ideal cycle. But here the compressor and turbine each have an efficiency of 80%, so that due to the friction losses there is an increase in work input to the compressor. So let us say this is 2 dash, and due to the frictional losses there is a decrease in work output in the turbine. Let us say this is 4 dash. So this is the actual cycle now. So here first we will have to find out all the values at all the points 1, 2, 3, 4 and 2 dash. So this is the cycle without regenerator. First calculate the efficiency for the cycle, and efficiency of the Brayton cycle is given by the work done by the turbine minus work input to the compressor or work done on the compressor to the heat input to the cycle. Okay, here first we will have to calculate the work done by the turbine. Work done by the turbine is equal to MCP T3 minus T4 dash. Let us say this is T4 dash. And here work done on the compressor is equal to MCP T2 dash minus T1. And here heat input to the cycle is equal to MCP T3 minus T2 dash. So first we'll have to find out all these values. To get these values, first we'll have to find out the temperature at different limits or different points. And here the known values are the regenerator efficiency is 75% or 0.75, and here the air at the inlet to the compressor is at P1 is 0.1 megapascal and T1 is 30 degrees centigrade or it is equal to 303 Kelvin, and here pressure ratio RP is equal to 6 and the maximum cycle temperature is 900 degrees centigrade, and in this cycle the maximum cycle temperature occurs at the point 3, that is T3 is equal to 900 degrees centigrade, so which is equal to 1173 Kelvin. And here the turbine and compressor have each an efficiency of 80%, that is efficiency of the turbine and efficiency of the compressor is equal to 80%. Now here we know that for an isoentropic compression, T2 by T1 is equal to P2 by P1 whole power of gamma minus 1 by gamma, or Rp power of gamma minus 1 by gamma, where P2 by P1 is the ratio of pressure ratio, and we can say that in the same way in isoentropic compression also T3 by T4 is equal to Rp power of gamma minus 1 by gamma, and here Rp is given by 6 and gamma is equal to 1.4, so that here T2 is equal to T1 into 6 power of 0.4 by 1.4, and here T1 is 303 Kelvin, and from this we can get the value of T2, that is equal to 505 Kelvin, nearly 505 Kelvin. And here from the T3 by T4 ratio, here T4 is equal to T3 by 0.6 power of 0.4 by 1.4, so which is equal to T4 is given by 703 Kelvin. Now here we got two values, that is T2 and T4, but we have to find out the T2 dash and T4 dash. So efficiency of the compressor is equal to here T2 minus T1 by T2 dash minus T1, and the efficiency of the compressor is 0.8, and from this equation we can get T2 dash is equal to nearly 252 Kelvin. And coming to the efficiency of the turbine is given by T4 dash minus T1 by T4 minus T1 is equal to 0.8, and from this equation T4 dash is equal to, sorry, here T2 dash is equal to 250 plus 303, so which gives a value of 555 Kelvin. Here 555 Kelvin, and coming to the efficiency of the turbine is equal to T3 minus T4 dash by T3 minus T4. So from this equation efficiency of the turbine is equal to 0.8, and from this equation T4 dash is equal to 798 Kelvin. So now we have all the values at different points. Now we can calculate the efficiency of the cycle. So that is equal to efficiency of the cycle is equal to Wt minus Wc, that is work done by the turbine minus work done by the compressor, is equal to heat input, and here work done by the turbine is equal to MCP T3 minus T4 dash. Let us say M is equal to 1 kg and Cp is common for all, so that T3 minus T4 dash minus work done by the compressor is T2 dash minus T1 by, here it is equal to T3 minus T2 dash. Now substitute all the values here, so that we can get here the efficiency of the cycle is nearly equal to 20%. This is the efficiency of the cycle without regenerator. Therefore in the option the right answer is B. B is the right option for the first question. And here coming to the second question, here we will have to find out the percentage increase in the cycle efficiency due to the regeneration. So here due to the regeneration, now again draw the Brayton cycle on TS coordinates. So here this is 1 to 2, 2 to 3, 3 to 4, and here again there is a decrease in output due to the friction losses, and there is an increase in work input due to the friction losses. This is 2 dash. And here due to the regenerator, there is an increase in efficiency or there is a decrease in heat input. So up to some point, let us say this point is indicated by 6. Okay, now here the efficiency of the regenerator is given by T6 minus T2 dash by, here it is T6 minus, sorry, T4 minus T2 dash, T4 dash minus T2 dash. So this is the efficiency of the regenerator, and here we know all the values T4 dash, T2 dash, and we will have to find out the T6, and here regenerator efficiency is given by 75%, that is it is 0.75. So from this equation the T6 is equal to, we can have here 737 Kelvin, 737.3 Kelvin. So here heat input is given by MCP T3 minus T6. So now substitute these values in the efficiency of the turbine, which gives a value of, here net work done, that is WT minus WC, as we calculate in the first question. Just substitute all the values here, so which gives a value of 28.31% yearly. And here we will have to find out the percentage increase due to the regeneration, and percentage increase is equal to 0.2837 minus, that is 0.2 by 0.2, so which gives a value of nearly equal to 42%. So it is 42.56%. So in the option the right answer is A. A is the right answer.